When we first hear the word oil, what comes to mind? The recent BP oil spill, perhaps? We all know how devastating the spill was and what its effects were on the environment and surrounding wildlife. I was intrigued when learning about the oil spill, so I decided to choose the topics how oil spills can produce mixtures that are hazardous to the environment. Now, this topic is directly related to our chemistry textbook, chapter 14.5, which goes through the impact of petroleum products. To give you an overview, I'm going to be covering multiple topics in this video. I will first give a brief explanation as to what exactly oil is, what its physical properties are, and what the fate of the spilled oil may lead to. To begin, oil contains a broad range of hydrocarbon-based substances such as hydrogen and carbon. Although most may think this only includes products such as crude oil and petroleum products, it can actually include animal fats, vegetable oils, and other terrible petroleum oils. However, with each oil comes different physical properties, which will affect the way the oil will spread and break down. When in bodies of water, such as lakes, oceans, and rivers, the oil is capable of breaking down through means of horizontal diffusion and dispersion. Horizontal diffusion occurs when a substance goes through from a high concentration to an area of much lower concentration. This allows for the oil to spread out throughout the water molecules and severely harm the life under the water. Dispersion is when these oil molecules are evenly spread throughout the water, causing an equal amount of harm as the horizontal diffusion did. The same oil spill in that body of water also goes through the process of evaporation into the air, which allows for the release of toluene and benzene. These substances are extremely dangerous for humans as well as animals to breathe in, as they are highly toxic and poisonous. I am now going to perform a quick demonstration showing everyone what happens when oil reaches the water. So what I'm going to do is I'm going to pour about 1/3 of a glass of oil into 2/3 of a glass of water. Now, this oil I'm using is not petroleum oil, it's just regular cooking oil, but it will definitely serve the same purpose as what I'm trying to show. So what I'm going to do is I'm going to pour the oil in. And I'm going to bring this a little bit closer so everybody can see. There we go. So as you can see, the oil is staying on top of the water. Okay. So what this means is that when the oil gets into our water streams, no matter whether it's from underneath the water or on top of the water, it's always going to form what's known as a slick on top of the water surface. Now, these slicks are very, very, very harmful to marine environments. What happens is these slicks of oil are very dark and dense in color, and they have a tendency to be very thick, as you can see in this oil demonstration here. So what happens is, since it's so dark, the light coming from the sun going into the marine environment can't go through. Therefore, all the underwater plants cannot produce photosynthesis, therefore not giving the marine life enough oxygen to breathe. And they ultimately end up suffocating and dying, which is exactly what happened during the recent BP oil spill, which happened about a year ago. So I hope everybody enjoyed that experiment, and I hope it actually helped people understand what is going into our water streams today, and exactly what happened during the BP oil spill as mentioned earlier. So although these spills can be deadly to the environment, natural actions can actually take place to help reduce the severity of this oil's effects once it reaches the water. These natural actions include, we have weathering. I'm just going to write that down. So we have weathering. We have evaporation. We have oxidation. Sorry, I'm just going to put it down here. Oxidation. We have biodegradation. Emulsion. Sorry if I'm writing a little bit on a slant. There we go. So, starting off with weathering. Weathering is what causes the oil to break down and become heavier than water through means of both chemical and physical changes. It allows the oil to sink down to the bottom of the water in the ocean. So when I just showed that experiment there, you could see that the oil was just staying on top. But when weathering occurs, it actually becomes so heavy in comparison to the water that it goes straight down to the ocean floor. And although it may look like there is no more oil, it's actually down on the ocean surface, which is also very dangerous because it will not get removed if it's not clean. So the next one we have here is evaporation. So as mentioned earlier, evaporation is when the lighter components of the oil are turned into vapor and they get placed into the air. However, not all oils can evaporate. As mentioned before, vegetable oil and animal fats are much less likely to evaporate than something such as petroleum oil, which has a much lower viscosity. Now, what happens is when everything evaporates, it releases deadly toxic chemicals into the air, which are terrible for us to breathe, which are toluene and benzene, both of which I had earlier mentioned to everybody. The next one we have here is oxidation. So oxidation occurs when the oil mixes with all the surrounding water, and it allows for the oxygen to come into contact and mix with the hydrocarbons and produce water-soluble chemicals. However, this allows for the formation of tar balls, which have the ability to wash up onto the shore long after the spill occurs. And you can imagine, even after the seafood oil spill, if not everything was cleaned up out of the water and oxidation occurs, imagine what those shorelines could look like in 10 to 15 years, whereas they thought they managed to clean up all the oil, but you never know. Now, over here, biodegradation occurs when bacteria, which is a type of microorganism, feeds on the oil hydrocarbons. These bacteria are highly encouraged to eat the hydrocarbons, and to entice these bacteria to eat the hydrocarbons, nitrogen and phosphorus can actually be added to the water. However, this process has a tendency to only work in warmer climates and warmer water temperature, because as we know, higher temperatures means that the bacteria are moving much quicker, much faster, and they're able to reproduce quicker as well. And the last one we have here is emulsification. And that is a process that forms water and oil droplets during wave action. So what happens is the waves will come and the oil and the water will actually combine and create thick droplets. Unfortunately, the oil and water emulsions only give the appearance that the oil is gone, when in fact it, like during weathering, is still sitting at the very bottom of the ocean. So I'd like to thank everybody for watching my video about oil and the mixtures it creates and the danger it poses, but also that it does have positive effects that even I just found out and just learned. So I hope everybody enjoyed the presentation, and don't hesitate to ask me any questions if you have any. And also there is the handout with everything that I mentioned, point form and summary, easy to understand with diagrams. So I hope you enjoy, and thanks for watching.